oxygen and
Molecular.
hydrogen.
No, but
No, you cannot separate.
Yeah.
It is not easy to separate it.
Sure.
Can only change from ice to liquid to gas. But when it comes to separation, probably when you go to Form 4.
It is
Now,
hard for oxygen.
There's someone who is still spoiling the screen.
Please stop.
Wherever you are, can you stop? We cannot
Please
continue
stop
like this.
Excuse me, Chair.
Yes?
It is hard.
Dad,
Who is this?
screen.
Because we cannot continue like this.
Excuse me, Chair.
Yes.
Watch out, Toto.
Excuse me, Chair.
Sir, can
I have a
contribute?
question.
It is. Sir,
possible
can I
Can you hear your
contribute?
question?
Excuse me, Chair.
Can't hear your question.
It's possible that you can use two elements
I can't hear
two
you.
different compounds. Is it possible that you can use two elements to get two different compounds?
Yes, depending on how you are going to combine them. You see, you can use water, you can use oxygen and hydrogen to form water. You can also use oxygen and hydrogen to form a substance called hydrogen peroxide. So it depends on the combination. But what I would want you to know is that there are elements and there are molecules and there are compounds.
Excuse me, Chair. Excuse me, Chair.
Yes?
Chair, I have a question.
Ask.
How can water exist between a molecule and a compound? That's what I don't understand.
You see, we need to understand that we can have a cup that is made of glass, okay?
Glass.
And a cup that is made up of plastic, okay? Both of them are cups, is it?
Yes.
So, but the glass cup is made up of its molecules, or it is made of the particles that are making it up. Is that clear? And the plastic is made up of, okay, let's say the glass cup is white and the plastic cup is blue, okay? So we'd say water is like a white cup. It is a compound, okay?
Yes.
But it has molecules. Well, it is made up of, it is white, the cup is white in color. So the compound water is made up of molecules. The cup, the glass cup is white in color. Is it clear?
Yes.
Yes. Because we have water is a compound. We have this cup, it is made of glass, but it is white in color. So the water is a compound. What is it made up of? Molecules. Is it clear now?
Yes. Yeah.
I would want us to go through. I'm really not able to move on with this. I can see the one who is controlling this is just consistently disturbing the screen. I want to give us a video so that we can understand more on, we can understand more on what I'm just talked about.
Excuse me,
Yes.
Is there a way that you can determine a compound?
You just need to know them. There's no way of determining. You just need to understand what compound is. Okay, let's move on. I want to give us a video so that you can understand on the same.
Excuse me, Jack.
Yes.
I have a question.
You have a?
Saying that water is a compound.
Mm-hmm.
Yeah, there is some time that we add water, let's say to juice, dilute it, or to convert into something sweet.
Mm-hmm.
So does it mean that once let's say we want to dilute a juice, we are adding more elements? When let's say when we want to dilute a juice,
mm-hmm.
we are adding the molecules of the water into the juice that you want to dilute so that it can expand, or what happens at that time?
No. Now what now you are introducing is a different type of a different thing called dilution. Now you have a bit digressed to what we are discussing. What you are doing is what you're talking about is dilution. But here we want to know about water. Exactly. What is water? It is a compound and it is made up of molecules. Is it clear? Now, I'm going to show you
Water is a compound
a
made up of
video.
3 elements.
If you can understand more about just a minute.
I think you should have muted everybody before the video.
Kindly watch this and see the differences.
Cannot hear.
I cannot hear what the video is saying.
You cannot hear.
Yeah, we cannot hear what the
What did they say?
Hey, Baba.
No, we can't hear. Sorry.
Some of you are saying they cannot hear.
Yeah.
teacher, we are not here.
the video.
Yes, you
cannot
can.
hear
I had nothing.
cannot hear the video very well.
Then maybe I'll just be giving examples. I'll just be explaining because I cannot turn the volume any further. It is on maximum. Depends on the quality of the video.
Teacher, I
Now,
suppose you mute everyone.
Yeah, you permanently mute everybody so that we can hear.
Yeah.
okay.
Try meeting everybody.
Yeah.
Teacher, what if you mute everyone?
Everyone to be muted.
Yeah, I've muted everyone.
So before you really start chemistry, you need to understand and be able to define some of the key terms. Today, we're going to be looking at 3 key terms: an element, compound, and mixture. Enjoy. So atoms make up absolutely everything in the world around you. Today, we're going to be using these small mollywood balls as a model for an atom. Obviously, atoms are way, way, way smaller than this, but we're going to use this as our model today. What you can see that I've got here is several different types of atoms. And if we organize them into sections of the same type of atom, we can then call those elements. Now, surprisingly, there's only actually 118 elements that have been discovered so far, and you'll find all of them on your periodic table. Element is defined as something that is only made out of one type of atom. So if it contains any more than one type.
I don't know what to do.
Atom, then it cannot be classified as an element anymore. Check out these examples. Which one do you think are elements and which ones do you think are not elements? Pause the video here, see if you can work it out.
Now, let me pause there. In this video, we have different models. We have this one. You can see that they are made of the same color of beads. This one has two different types. This is white, this is black. This is white, white, and black. Then again, this is blue and blue. This is green and green. This is green and blue. This is also white and red, or whichever color. And again, we have these two. These are models that can help us to understand which ones are elements, which ones are compounds, which ones are, what can we say about them? I would want you to tell me the first one that is gray in color, if someone can tell us. Is it an element or is it a compound? Hey. You can unmute.
It is an element.
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 It's an element because it is made up of one type of element. This other one with
Element.
element,
Only
a
one type of
compound.
atom.
Element.
Element.
And one.
Element.
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 Is a compound. This one is a compound with white.
Compound.
Element.
Element.
Yeah, I think it must be an element.
This one with green and blue.
Compound.
Compound.
Made up of compound. They are different.
Element.
Those are examples of.
Compound.
Let's continue with the video. With the.
Mute us again.
Mute us again.
Okay, just a minute.
Mute.
Mute.
All of the same type, or in this case, the same color. So what you've got is these three at the top here that all contain only atoms of one type. All of the ones at the bottom all contain more than one different type of atom. They all have multicolored molymod balls. The question you might be asking now is, what do we call the three at the bottom? So the top three are elements. They contain one type of atom. The bottom three contain two or more types of atoms. They have different colored molymod balls. We call these compounds. And compounds have to be chemically combined and contain two or more atoms. The last word that we have to look at today is, what is a mixture? And what we've got here is one type of atom, just the red balls here. So these are all the same element. They're all the same type of atom. If I put some white atoms next to these, but not connected like the last ones were, we call this a mixture. So we define a mixture as two or more substances that are not chemically combined. So you can see that they're not really touching each other. They don't have the sticks in them showing that they are chemically combined in this case. Check out these examples here. One of them is a mixture of compounds, and one of them is a mixture of elements. Can you tell which one is which?
Now, there's a question there. We have this part, it is a mixture. And again, this is a mixture. I think we had not talked about a mixture, but it is a combination of two or more substances that are not chemically combined. So I would want you to tell me which one is a mixture of elements and which one is a mixture of compounds. Is it the one on this side, on the left side, or on the right side? On the left, yes?
Is an
element.
mixture of elements.
Mixture of
Right is a mixture of compounds.
Correct, that is good. On the left, we have a mixture of elements.
Elements. Elements.
Let me mute you so that you can continue with the video.
The ones on the left are a mixture of elements. What we've got here is we've got three different elements, so three different substances that only contain one type of atom. If they're in the same container, that means that they're a mixture because they're not bonded together. On the right-hand side, I've got a mixture of compounds. Each one of these species contains more than one colored ball, and that means more than one type of atom, so that makes it a compound. Because all of them are different, they have to be a mixture of compounds. If I mix all of this together, that now means I've got a mixture of compounds and elements all together. So hopefully you feel more confident in defining what an element, compound, and mixture is after watching this video.
Okay, so that video has given us some information about elements, compounds, and a mixture. I hope it is clear. Is there any question? I can see our time is far much spent. I would want us to go to the last part of our lesson, because we have learned about an atom, an element, a molecule, and a compound and a mixture. Then we need to give some differences between compounds and mixtures. That's our focus for now. And in the differences, I want to take us through. We have mixtures. We've already seen the definition of a mixture. And it is a substance that consists of two or more elements or compounds that cannot be that are not chemically combined. There are characteristics of mixtures. And we have its properties are the average of the properties of an element. Its components can be separated by physical means, that is filtration, magnetism, distillation. Its components are not necessarily mixed in fixed positions and are formed by physical means, that is There's no heat that is used. I've gone through these ones. You'll be getting the notes in our class, so don't worry about it. A mixture. Let's look at examples of mixtures. One is air. Air is an example of a mixture. Why? Because in air we have oxygen, we have nitrogen, there is carbon dioxide, there is water vapor, and there are the noble gases. Therefore, water, air is an example of a mixture. It contains two or more elements of compound or compounds that are not chemically combined. Another example is sugar solution. It is a mixture of sugar and water. And I think there's someone who had asked about water and juice. It will fall under the category of mixtures because these are two substances that are combined. Sugar and water. Sugar solution is a mixture of sugar and water. Seawater. Now, seawater is a mixture. This mixture is made up of water and dissolved salt. Now, there's an experiment that is done so that we can give the differences between a mixture and a compound. Sorry about that. I want you to be very keen on this mixture because it is a very common question that comes in the exam and I want you to understand. Now, before that, I have a video for this, so I'm going to be showing you in a while. Now look at the apparatus. We have a watch glass. I hope you can remember those apparatus. There's a test tube, a wooden splint, a magnet, iron filings, sulfur powder, dilute hydrochloric acid, that is an acid. Now, these are experiments and procedures. These are apparatus and reagents that will be used in the experiment. I want you to consider this, iron filings. Iron filings is an element. Sulfur powder is another element. So we want to take two elements. When we take iron filings and sulfur, we will make both a mixture and using the same two elements, we make a compound. And then once we make a mixture and a compound, we see the differences between the mixture formed when you combine iron filings and sulfur, and again, the compound formed when you have iron filings and sulfur. The important thing is to note you can take two substances, make a mixture, again, the same two substances, and make a compound. And after this, we will be looking at the differences. Now, in the video, I'm going to share, I would want you to consider the color of the mixture and the compound, iron sulfur mixture, and the iron 2 sulfide. This is the compound formed when you combine iron and sulfur chemically. So iron sulfur mixture is a mixture. Iron 2 sulfide is a compound. So one thing that I would want you to check is the color. Number 2, color of the mixture and the color of the compound. Number 2, I would want you to look at, can they be separated? Is it possible to separate the mixture? Is it possible to separate the compound? Number 3, how do they react with dilute hydrochloric acid? Of course, I'll be giving more examples, other substances that will be reacting. And then what happens when the mixture is heated and the compound is heated? So I'd want you to see the differences between a mixture and a compound. Now remember, a mixture of iron sulfur has been made. Then we will make a compound called iron 2 sulfide. Iron 2 sulfide is made up of iron and sulfur chemically combined. Let's look at the video.
distinguish between mixture and compound. Using a spatula, take a small quantity of sulfur powder and transfer it into a beaker. Add a small quantity of iron fillings into the same beaker using a spatula. Stir the contents of the beaker using a glass rod and label this mixture as A. Take a china dish and using a spatula transfer a small quantity of the mixture into it. Heat the contents in the china dish strongly by placing it on a wire gauze that is placed over a burner. Stir the contents constantly till a black mass, that is compound of sulfur and iron, is formed. Cool and transfer the contents into a mortar and powder this using a pestle. Then transfer the powdered contents into another beaker using a spatula and label it Black Mass B. Test on the basis of appearance. Take a small quantity of mixture A and black mass B in 2 different watch glasses. Mix the mixture A in the watch glass using a glass rod. You will see yellow powder in which some iron fillings are visible. Then mix the black mass B in the watch glass using a glass rod. No iron fillings are visible in the black mass B. Thus we infer that a mixture is heterogenic and compound homogeneous in nature. Behavior towards a magnet. Place a small quantity of mixture A in a watch glass and a small quantity of black mass B in another watch glass. Show a magnet over the watch glass in which mixture A is taken. Iron fillings cling to the magnet since iron retains its properties. Show the magnet over black mass B. No particles attach to the magnet because iron loses its magnetic properties on forming a compound. Behavior towards carbon disulphide. Take a clean test tube and put a pinch of mixture A into it. Add a few drops of carbon disulphide into the test tube. Shake the test tube well. Sulfur first dissolves, reappears after some time. When in the form of a mixture, sulfur retains its property. Take another test tube and put a pinch of black mass B into it. Then add a few drops of carbon disulphide into the test tube. Shake it well. No changes observed. In compound state, FeS, sulfur lost its original properties after reacting with Fe. Action of heat. Take a small quantity of mixture A in a china dish. Heat the mixture strongly. A black mass is obtained which is homogeneous. A compound of iron fillings and sulfur powder, FeS, is formed on heating. Take a small quantity of black mass B in another china dish. Heat it strongly. No change is observed. The compound FeS does not show any reaction on heating. Effect of heating with dilute HCl. Take a small quantity of mixture A in a test tube. Add a few drops of dilute HCl into it. Cork the test tube. Connect the test tube to another test tube with a bent tube. Heat the contents of the test tube gently. A colorless, odorless gas evolves. collect the gas in the other test tube through the bent tube. Now remove the bent tube. Bring a glowing matchstick near the mouth of the test tube. The flame dips out, producing a popping sound, and with a mild explosion. The gas evolved is hydrogen gas. Now, take a small quantity of black mass B in another test tube. Add a few drops of dilute HCl into it. Cork the test tube. Connect the test tube with the bent tube to another test tube containing copper sulfate solution. Heat the contents of the test tube gently. A colorless gas evolves that reacts with copper sulfate to form a black colored precipitate. The gas evolved is hydrogen sulfide H2S, which reacts with copper sulfate to form black precipitate of copper sulfide.
Okay. So that is that shows an experiment on compounds and mixture. And I would want us to go back after watching that video. And again, from what we have watched, considering the color of both the iron sulfur mixture and the iron 2 sulfide, the compound that was formed, you realize that the substance, the mixture was yellow-gray due to the yellow sulfur and the gray iron powder. Again, the iron 2 sulfide, the compound that was formed, was black in color. The yellow-gray mixture changes to a black solid. So that tells you that is one difference between the iron, the mixture, and the compound. Number two is about separation. For the mixture, the iron and sulfur can be separated using a magnet because it is a mixture. However, the iron 2 sulfide, it cannot be separated using a magnet because it is already a compound. It is a substance that cannot be separated by any chemical means. It's a compound. Then once again, when the mixture is reacted with dilute hydrochloric acid, a gas is produced. That is, hydrogen gas is produced. On the other hand, when you react hydrochloric acid with iron 2 sulfide, a different gas is produced. And this gas is called hydrogen sulfide. So the mixture and the compound are giving different gases. They are producing different gases. That tells you the two are different. And lastly, when the mixture is heated, heat change. When the mixture is formed, there's no heat change. But when the iron and sulfur are heated, there's a change in heat. There's heat that is used, and once it is used, it forms a compound. So now that gives us the differences between a mixture and a compound. And I can see our time is up. Maybe what I can do is to share these notes so that we can get them and both of them. Because I would want you to note the differences between a mixture and a compound. I'd also want you to internalize and give the definitions of both a mixture and a compound. I'll also be sending the links to those two videos. You can continue watching those videos. you can continue watching those videos. Now, we may not continue. Our time is up. Unless someone has a question, unless someone has something that wants to confirm, I'll be sending the notes and I'll also be sending the links so that you can watch the videos again. You can have them.
Excuse me, teacher.
Yes.
Excuse me, teacher.
You have said when iron and sulfur, which compound do they form?
It is iron 2 sulfide.
The suffix ide.
And when you were explaining about the compounds and elements using the video, how do you know that these are through the video? Does it mean that the same colors are elements and different colors are compounds?
Yes, exactly. That is correct.
Sure.
Yes.
Will you send the notes to the West Forum?
Excuse me, teacher.
Oh, I'll send them to your form master, who is going to send them to the respective classes, because I'm a teacher in OneNote. I can only access OneNote. So I'll share them in OneNote, and then I'll share them with your form master.
Okay. Excuse me, teacher.
Excuse me, teacher.
Yeah. Yes.
When you say that air is a compound.
No, air is a mixture.
Mixture.
You said air is a mixture.
If air is a mixture, is krypton included in the mixture?
Yes.
The krypton.
So it is a mixture.
Excuse me, teacher.
Can we separate water?
If air is a mixture,
hydrogen and the oxygen.
Krypton included in the
There are two
mixtures
people,
of air.
asking a question. I cannot get to the two. Maybe one person at a time.
When we say that air is an element.
No, air is not an element. Air is a mixture.
Air is a mixture of what?
Where is a mixture of oxygen?
I think you are not deep when we started, because I've already covered that in the lesson.
Many gases like oxygen, carbon dioxide, double
I
gases.
know there are some who joined.
Nitrogen.
I've already covered that in the lesson. So thank you very much. Let me organize on how to share the links to those videos.
Bye.
Yes.
Excuse me, how can we separate the molecules in the water?
Krypton included in the
Feel
mixture.
free to, you can leave now.
If
At your
air
own
is a
pleasure.
mixture.
Oh, bye, teacher.
Bye-bye.
If air is a mixture,
Yeah, thank you for the lesson.
Thank you for
separating
the molecules.
Thank you. Thank you.
Yes, thank you for your time.
Thank you. Thank you.
Method can be used to separate the molecules in the water particles.
Bye, teacher.
Bye.
Okay, bye.
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 Thanks.